Welcome to this video on graphing exponential functions. By the end of this video, you should be able to graph the exponential function and identify key characteristics of that graph. So, exponential functions is the last function that we're going to talk about. An exponential function can be represented by y equals a times b to the x. Now, just like other formulas that we've looked at, the basic equation, the standard form, the letters have a particular place. B is always going to be attached to the exponent because sometimes a is 1 and so they don't put that in the problem. So there may not be an a value typed out. You need to know that the b value is always attached to your exponent. Now, an exponential function is a function whose successive output values are related by a constant ratio. And what they mean by constant ratio is a multiplier. It's going to be multiplied by the same number each time. Okay, and that is your b value. That's your ratio number right there. All right, now, when we're talking about our exponential functions, an exponential function has something called an asymptote. It's one of my favorite math words. Asymptote, right here. An asymptote is a line that the graph will approach, but it will never ever touch. It's going to get really, really close to this point, but it's never going to touch it. Okay? And so that's going to be an important part of a feature of a graph that we'll have to learn about. So there's two kinds of exponential functions that we're going to talk about. When you have an exponential function that moves away from the asymptote, it's called a growth. So what that means is if we have the coordinate plane, so here's my x and y axes, I'm going to draw in my asymptote. And so our asymptotes in Algebra 1 are always a horizontal asymptote. So I'm just going to say this is the line that the graph will approach but never ever touch or cross. Okay, so it's staying on one side. A growth exponential function will start really close to the asymptote and then it's going to shoot up and away from it. Okay, so that's what this says, that it's going to move away from the asymptote, because we always read left to right. It moves away from the asymptote. When we have a growth function, the b value, remember I was saying the b value is the number next to the x, the b value will be greater than 1, and the graph will increase as it moves from left to right. So that's our growth. And the other kind that we're going to talk about in this unit is decay. The exponential function moves towards the asymptote for decay. The b value, this number here next to the exponent, will be between 0 and 1 if it's going to be a decay. And the graph will decrease as it moves from left to right. So to show you the same idea, I'll have my x and y axes. I'm going to draw in my asymptote. And it's going to, your graph is going to decrease as it approaches the asymptote. That means it's going to start off real high, and it's going to come down and ride along the asymptote. Okay, so that's what a decay will look like. All right, now let's label a couple important things for our exponential graph. The overall thing that we're talking about are exponential functions, so we'll write in exponential function. Okay. We have graphed so far in Algebra 1, we have graphed lines. We have graphed a quadratic parabola, and this curve is called the exponential curve. All right. Then there's a couple points there's a point here that we should be familiar with. This is where the graph is crossing the y-axis. So this is our y-intercept. And then we have this one that's pointing to this dotted line. I'm just going to highlight this dotted line. If you have a highlighter handy, I would take it out. It would make this maybe a little easier in your graphing. That's your asymptote. That's the line the graph will approach but never ever cross. So for this one, you can see this is a growth because it goes away from the asymptote as we go left to right. And you see how close it is here. It's going to go forever to the left, but it will never cross that asymptote line. It just gets closer and closer and closer and closer and closer. All right. So what I want us to do is learn how to put our exponential functions into a calculator. So grab your graphing calculator, pause the video if you need to, and be ready to put the numbers into the calculator. All right, so with our calculator, we want to go to our number one problem here. It says f of x. That's the same as saying y. It just guarantees what comes after it is a function. So we see that notation sometimes. So we want to go into y equals, and we're going to put it just like we see it. So 3 parenthesis 2 and then close your parenthesis. Now to get the x up in the exponent, right here you have the little up arrow. You're going to press the up arrow and it takes you up into the exponent and touch the variable next to the alpha button, x. And then we're going to arrow over and watch, see how the cursor is next to the x? When I arrow to the right, it drops back to the main level. Okay, so because this plus 4 is not part of the exponent, it's back on the main level. So we go plus 4. And we're going to identify the y-intercept and the asymptote. So let's go look at our table of values. In our table of values, your y-intercept is always where x is 0. So our y-intercept in this case is 0, 7. Now for our asymptote, it's always going to be, we'll put this up here in our notes, we're always going to write it y equals. So we got y equals, and we want to figure out what the asymptote is. What is the graph going to approach but never ever touch? So if I'm scrolling down, I'm looking at my y values, and I notice they're just getting huge. Look at that. Look how big they're getting so fast. Okay, so let's go back the other way. We want where they're getting very, very tiny. Oh, now look here. 5.5, 4.75, 4.375. See how little change, but we're just getting more decimals. We're getting closer and closer to 4 as we're going, and then all of a sudden our calculator says 4. What's happened here, if we keep going, there's just a bunch of 4s. The calculator does not have enough space for all the decimals. So really our asymptote is at 4. The calculator says we're equal to 4 there. We're not. It just can't handle any more decimals. It's very, very tiny differences. It's just approaching and getting closer and closer to that y equals 4. Now look at the equation. Notice how there's this 4 on the end, and our asymptote was 4. Keep that in mind. Let's go ahead and try the second one. So the second one I want to point out, remember I said sometimes a is 1 and they're not going to type it in. So b is right next to the exponent. So that 2 is actually a b. So that means the a value is 1, and it's really 1 times 2 to the x. They just don't type it. Okay, so we're going to put this into our calculator, go into y equals, clear out anything that's in there, put in 2 raised to the x, make sure you drop back down to the main level and put minus 3. Once you have that into your calculator, we're going to go look. Oh, look, we were way back here in these negative numbers from the last one. Look at all those negative 3s. Do you see that? When you see that, that's your asymptote. So we already know the asymptote here, y equals negative 3. Now remember what I said, look, there's a 4 and there's a positive 4 and a positive 4. Now I have a negative 3 and a negative 3. So hopefully you're starting to see this number on the end tells you your asymptote. Alright, so let's look where x is 0 for our y-intercept, and that's 0, negative 2. So our y-intercept is 0, negative 2. Alright, pause the video, try these last two on your own, and come back when you're done to see how you did. Alright, so I got 0, 3 for my y-intercept, and y equals 1. There's a positive 1, so my asymptote's a positive 1. And for number 4, my y-intercept was 0.5. Now, I got y is 0 because on here there was nothing written after the exponent, so that's the same as saying plus 0, so that 0 would be my asymptote there. Alright, let's try practicing some of these on a graph. Okay, on the back of the note page, I've got some graphs, so we're going to put some of these equations on the graph, and we're going to answer some characteristic questions. We have one new characteristic that we're going to talk about. That's our end behavior. And so we have our asymptote, that's going to be that line. Range, y-intercept, domain, and behavior is new. Rate of change may sound new, but rate of change is actually just slope. So we're going to be using the slope formula there when we get to it. All right, so let's go to our calculators and let's put 2 raised to the x into our y equals. All right, and then we're going to go, we can graph it and see how it looks. Right, so that's our graph. Notice it's not going below that x-axis. It's riding kind of along it, and then it shoots up. It goes away from the asymptote. That makes it a growth. And if we look at the b value next to the exponent, b is greater than 1, so that's a growth. If this was a number between 0 and 1, it would have been a decay. So there is no number at the end. That's, remember, the same as saying plus 0. So our asymptote is at y equals 0. So I want to take my highlighter and I'm going to run it across the x-axis because that's where y equals 0. That line is y equals 0. So we know our graph is going to be really close to that if we look at it here, but it's not going to cross it or touch it. Okay? So let's get some points on. So go look at your table of values, and we're just going to pick some points to graph that are easy. These are not easy to graph. I'm not going to worry about them. But then when I look at -2, I can go up a quarter. -2 and up just a quarter. That's just a little bit. -1 is -1 and a positive 1/2, so it's just a little bit higher. And then we have 0, 1. Okay. We're just going to get a couple of points on here that we can graph easily. 1, 2, 2, 4, and 3, 8. That is enough points because we know on this left side it's going to ride right along our asymptote. So we're just going to have it come right along the asymptote. And when we get to the coordinate points we put on, we'll follow them and then we'll stick an arrow on our ends. Okay, so they look pretty much the same. Now we're going to answer some questions. Remember, when we talk about range, we're talking about y values. We read the graph from the bottom up. This is where the asymptote is very important. That is part of our range. So our asymptote here was 0. And our graph goes up from there. It never stops going up, so it's going to go on into where y's are at positive infinity. Okay? That's our range, but it has a special way that we're writing it. So it's going to start at 0. We're talking about y values, and they're going to go into infinity forever and ever and ever. Okay? Now remember, we used inequality symbols in here. We cannot be equal to infinity, so we just used a less than there because it's not possible to be equal to infinity. On the other side here with our 0, that's our asymptote. Remember, the graph never ever touches the asymptote, so we can't be equal to 0 also, so we're just going to use the less than sign there also. So this says all the y values are between 0 and infinity. Okay, our y-intercept, where does the graph cross or touch the x-axis? It's at where x is 0 and the y value there is 2. Our domain, that's your left and right. Notice there's an arrow on the left and an arrow on the right. That means it never stops. So that's the all real numbers. And in the past I've used the symbol, it's 2 lines and then you make it into an R. That also stands for all real numbers. Okay. And behavior, this is our new thing. And so you'll be given a sentence that asks about either the left or the right of the graph. So this says, as x approaches, the arrow means the word approaches negative infinity. Well, x's are negative infinity on the left-hand side, and x's are go into positive infinity on the right-hand side. So as x approaches negative infinity, that means they're talking about the left. On the left, as this graph goes out further and further and further, what's going to happen to the y values? Where are the y values going? Well, the y values are going to get closer to that asymptote the further left we go, but they're never ever going to cross it. So our y values are approaching 0. They're not going to get to 0, but they're approaching it. Now let's go over to the right-hand side, because this says as x's approach positive infinity, x's are positive on the right-hand side of the graph. So look at the right-hand side of the graph. What are the y values doing there? They're going up to positive infinity. They're never going to stop going up from there. Okay? Now I want you to look that your range and your end behavior are tied together. They're going to have the same values. You just have to make sure which side is are we talking about, the left or the right, because it depends on whether it's growth or decay where the numbers go. Okay? And then our last one is our slope. So what this sentence says here, rate of change is slope. I have 0 is less than or equal to x, which is less than or equal to 6. These are x values. So if I'm given the x values, I want to know the y value. So I have an x value of 0. And when I look at my table of values, an x value of 0 has a y value of 1. Which makes me realize I told you the wrong number on my y-intercept because I misread the graph. So I apologize for that. So that 2 is actually 1. So hopefully that doesn't mess us. Dr. H just can't read a graph. Okay, so 0, 1 is one of our points. The other point that we're interested in, the x value is 6. So I'm going to go look at my table of values where x is 6. And my y value there is 64. Okay? I have 2 points, so we're going to use the slope formula. Quick review of the slope formula. It's right here. It says y minus y on top divided by x minus x. Notice they're in the same order, the points you start in. Okay, so I'm going to say y minus y, so that is 64 minus 1 divided by, going in the same order, I did 64 minus 1, so I'm going to do 6 minus 0. 6 minus 0. 64 minus 1 is 63. 6 minus 0 is 6. And that will reduce down. 3 goes into both of those, so 21 over 2. That's a pretty steep slope. And when you look at this, this is really saying from here, you're going to go up, from this number, you're going to go up 21 and right 2, up 21 and right 2 to get over to where you want to be, is really what this is telling you. So, very steep slope. All right, let's try this again. We're going to put this into our graphing calculator and start answering the questions. All right, once this is in your calculator, always make sure that it says the same thing, that you haven't accidentally put your minus 1 up in the exponent, that you remember to drop down. I'm going to tell this to graph it so I can just look at it. And here's my graph. It's going towards the asymptote as we go left to right. That means this is a decay problem. It starts high and gets low. This is decay. And right there, look at your b value. Your b value is between 0 and 1. That's how we could tell just by the equation if it was growth or decay. So for our asymptote, remember that's our last number off the end, so y equals -1. So I'm going to go ahead and put that on my graph. Y equals -1 is this line here. So that gives me a visual of where my asymptote is. We're just going to pull some points off. So look in your table of values. And so we can't go too far back. We can go do -1, 7. So -1 up 1, 2, 3, 4, 5, 6, 7. Remember, it's going to start high and come low. Then we have 0, 3, 1, 1, 2, 0, 3, -1/2. So you go halfway down. 4, -0.75. That's probably enough. We're starting to see that exponential curve showing up. So I know it's going to start real high. We're going to go through these points, and then we're going to ride along our asymptote for the rest of the time. Okay? All right. Now let's answer some of these questions. For our range, remember our asymptote is very important in our range. Our asymptote is at -1. And from -1, the graph goes up forever and ever and ever into positive infinity. So to write that, we're starting at the bottom at -1. It's going to be less than y. which is less than positive infinity. Our y-intercept is right here at 0, 3. Our domain, our graph is never stopping going left and is never stopping going right. So remember, that's going to be all real numbers. End behaviors. Okay, let's look at this. This says as x approaches negative infinity. That's the left-hand side of the graph. So as x approaches negative infinity, where's the graph going for my y values? Is it by the asymptote or is it going into an infinity? This one is going up forever and ever, so my y's are going into positive infinity. And as x approaches positive infinity, that's the right-hand side of the graph. The y values, you see how they're right next to the asymptote there? And the asymptote is -1. So when I look, I've got -1 and infinity on my range, and I have the same thing on my end behavior. That will always happen because they match together. Now we're going to do our slope again. So I have two different x values here. I have an x of -1, which gives me a y value of 7. And my other x value is 2. So when I go to where x is 2, my y value there is 0. So I'm going to use my slope formula of y minus y. So 0 minus 7 divided by, and I went 0 minus 7, so I got to go in the same order, 2 minus, and there's a -1. So whenever you have minus and negative, remember, that turns it into a positive. So 0 minus 7 is -7. 2 plus 1 is 3. And that's not going to reduce anymore. So we're showing a negative slope, which we definitely have between, here's where x is -1 and x is 2. We have a negative slope going on there. All right, one last one. Pause the video and put this into your calculator and take a look at the graph, and then come back once you've got it all in. All right, so I put my equation into the graph. Hopefully you started thinking, gosh, there's a negative sign out front. The other ones didn't have a negative sign. When we look at our graph, do you notice how this is going down? And it's different than a decay going down. So what's happened is that negative sign in the front has flipped the graph over, just like when we had quadratics. They were U-shaped, but if the first number was negative, the U was upside down. Okay, so this is the same idea. It's just been reflected. Okay, so let's take a look at our equation. So the b value is more than 1, so that you would think growth, but once we have this inverse for our Algebra 1 world, we're just going to call it neither. When it's underneath the asymptote because it reflected over, it's neither growth or decay. Okay, we're just going to call it that. You'll learn more about that in Algebra 2. So our asymptote, it's our last number, is at y equals 1. So I'm going to highlight that on my graph to help me know. Now, what will be different is when we start graphing, we're not going to be above the asymptote, we're below it because of that negative sign in front. So let's look at our points in our table of values. So I've got -2 and a positive 0.25, -2 and up just a tiny bit, -1 and -1/2. 0, -2, 1, -5, and 2, -11. That's just off the graph down here at the bottom. That's enough to get us the idea, and we can mimic kind of what we saw here, is that we ran along that asymptote on this side, on the left, and then we're going to follow our points, and then they're going to go down forever and ever and ever. Okay, so we had a reflected situation here. It's neither growth nor decay. Technically, it's inverse growth, but that will be a discussion for another day. So let's talk about range here. So our range, let's label the important stuff. We know the asymptote is important. That's at 1. So before, the graph was going up and up and up, but this graph doesn't. This graph is going down. The y values down there are in negative infinity. Okay, Now, for range, though, we always read from the bottom to the top. That's how we read these others, from the bottom to the top. So the first thing that we're going to get is negative infinity. So we got negative infinity. Can't be equal to that. And then we're not going to go past 1, and we're not going to be equal to 1 because that's our asymptote. Okay. Our y-intercept is here at 0, -2. Our domain is never stopping left or right, so that's your all real numbers. End behavior. Okay, let's pay attention. As x's approach negative infinity, that's the left-hand side, so this is where x's are negative infinity. See how it's right next to your asymptote right there? And your asymptote is 1. Okay? On the right-hand side, as x's approach positive infinity, so they're talking about the right-hand side of the graph, what are the y values doing? They're going down forever and ever into negative infinity. Notice it matches your range as it should. Now, let's do our slope. Looking at our table of values, our x value is 0, so we have 0, -2. Our x value is 3, and our y value there is -23. So 3, -23. Okay, so now we're going to use our slope formula. So we have -23 minus -2 divided by 3 minus 0. So that negative becomes positive. -23 plus 2 is -21 divided by 3, which will give us a slope of -7. All right, hopefully that was helpful. Let me know if you have any questions, and I'll see you in class.